Lines. So our definition for parallel lines, please write the following. Parallel lines are two lines that do not intersect. So parallel lines are two lines that do not intersect. Within that box, I want you to add some notation. Okay, whenever we have parallel lines, remember the upside down T was perpendicular?
Yes.
So if we do two lines right next to each other, that means parallel. So that's like your shorthand notation for the word parallel. So if you wanted to use that instead of writing out the word parallel, you're more than welcome to do that. Also, when we are describing parallel lines visually, so if these are my parallel lines, remember when we put tick marks on line segments, what does that mean? The same length. So to show that we have parallel lines, sometimes you'll see something like a little triangle. I should not have done pink. Let's go orange. You'll see like a little triangle happening on the middle of the lines, and that means that they'll be parallel. So if you see like lines with arrows or triangles within the line, that tells you that they're parallel lines. Huh?
Very, like, somebody licked the cheese powder off of her desk.
Does? All right, so parallel lines. Two lines that will not intersect. So skew lines are going to be two lines that do not intersect. So two lines that do not intersect and are not coplanar. So they can't be in the same plane. So if we think about the room right now, we've got the top line where the ceiling and the front wall meet. Does everybody see the line I'm pointing to right now? Okay. So if I wanted to pick a skew line to that line, where would it be, Aiden? Bottom corner of the floor and the side wall?
Bottom ketchup wall.
Good. Either of those would work. So skew lines, parallel lines. This line would be parallel to this line down here. This line would be parallel to the back line back there. Okay? If you think about real life examples, if you're driving north on 95, have any of you guys driven past the Kennebunk?
Mm-hmm.
Okay, so you've gotten past Kennebunk, right? Oh, yeah. So right at the Kennebunk rest stop, there is the Green Eastern Trail, bike riding trail. Have you guys noticed that at all? Mm-hmm. So there's like a path that goes over top of 95 that people can run on and ride their bikes on. Yeah. So if you're driving on 95 north and you go underneath that trail, you are not going to intersect it, right? Because you're going underneath it, but it's going over top of you. So you guys are not on the same plane, but you're not parallel with each other. Because people going southbound would be parallel to you, right? So we got that being parallel, and then that overpass would be skew to you. So you're going in opposite directions, and you're not intersecting, okay? All right, so skew lines, parallel planes are two planes that do not intersect. So two planes that do not intersect. Okay, so similar to what you guys just did in that little intro activity, there's a box with a whole bunch of lines on it. I know that we are not told specifically that they're right angles, but we're going to assume for this example that it is square. So it's not giving you the little right angle box in any of the corners, but we're going to assume it. So let's go ahead and answer these questions. So part A, we need to come up with all the lines that would be parallel to line AB. So if you look up here, you can see it in color. There's line AB in red. But I need to specifically pick a line that has point D in it. So just to make sure we understand which all points. So DC is a line containing it. AD is a line containing D. DE is a line containing it. DG and DH would be all the lines that have point D on it. Out of all of those, which one will be parallel? DC, good. So line DC would be the only line parallel to AB that has point D on it. There's a bunch of lines parallel to AB. EF is parallel, GH is parallel, DC is parallel, but that's the only one that contains D. Okay? All right, part B. Which line is skew to AB containing D? DH would work. That would be one. DE would work. DG would work. Any other ones? DA would intersect. DC would be parallel. So I think that's it, right? Just those three? Those would all be skew to line AB containing D. For part C, oops, come back. Which line is perpendicular to AB containing point D? DA. Again, and that's assuming that it's a square box. So DA would be the only one that would be perpendicular to AB. BC would also be perpendicular. AE would be perpendicular, and BF would be perpendicular, but this is the only one containing point D. Okay? And then the last one, planes parallel to plane EFG. So EFG is which plane? EFG looks like it's the bottom of the box. So what's parallel to the bottom of the box? The top of the box. How would you name that? DAB would work. The DAB plane. BCD would work. ABC would work. Okay, so those will be all of our planes parallel to the bottom of the box. Plane, parallel planes, parallel lines, skew lines. We're good with that?
Yep.
Okay, on to the next. We got the parallel postulate and the perpendicular postulate. I'll read through this slowly so you can get it all written down. So the parallel postulate says, if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. So what does this look like? If you have a line, let's call it line M. And you have a point, let's call it point A, somewhere not on the line. How many possible lines can I cut through A that would be parallel to line M?
One.
Just one, right? So there's only one possible line that can go through that point, let's call it line L, that would be parallel to it. How many possibilities do you have to make a perpendicular line? Just one. So your perpendicular postulate is just rewriting the parallel postulate, except with the word perpendicular in it. Okay? So your perpendicular postulate, if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So perpendicular postulate. If there is a line, so here's my line M, and to point A, there's only one possible line that's going to be perpendicular to it. Okay. All right, we've got parallel postulate, perpendicular postulate, skew lines, parallel planes, parallel lines. Let's look at the playground example. So here the figure shows a swing set on a playground. Name a pair of perpendicular lines.
GK, FJ.
GK, those would not be perpendicular. What would be perpendicular to line CN? Perpendicular to CN. CN's all the way across the top.
GK.
GK would work. Good. GK would be perpendicular. It's one pair. What would be parallel to CN? JK. Good. Okay. Is DH perpendicular to line to LM? So here's DH. If I continue DH all the way through, and then LM kept going through, would they be perpendicular? Yes.
On a 2D surface.
Yes, they would be perpendicular. Okay, if we continue those lines all the way through. All right. We got parallel, perpendicular, skew. All right, we're going to pause and do is a line that intersects two or more coplanar lines at different points. Okay, so a line that intersects two or more coplanar lines at different points. So when you guys had your two lines, you drew in your transversal. Didn't matter what angle your transversal came in, you made your transversal. Okay? All right, so angle pair relationships that occur. Our first one is, sorry, I'll go back. Where are you at? More coplanar lines at different points?
Okay, what I just wrote is not English, but maybe I can read it.
Okay. All right, so corresponding angles. When we have corresponding angles, you are going to have angles on the same side and one interior and one exterior. So we kind of call that corresponding positions. So here I have labeled 1 and 5. So notice 1 and 5. 1's on the exterior, 5's in the interior, but they're on the same side of the transversal. Those would be an example of corresponding angles. Okay, so over here, corresponding. 1 and 5, 2 and 6, 3 and 7, 4 and 8. When you come up with these angle pair relationships, you always are going to pick one from the first cluster, a second one from the second cluster. Notice how 1 is top left, 5 is top left. Top right, bottom right, bottom left, bottom left. Corresponding positions for corresponding angles. Okay? Everybody's got that one? All right, alternate interior are going to be on opposite sides.
Wouldn't that be 3 though? Right there with the forward.
Yeah, I had it labeled differently. So opposite sides and interior. Does that make sense if we just say that? Opposite sides and interior. So opposite interior, so alternate interior angles. Alternate exterior are going to be opposite sides and exterior. So here I have 1 and 8, which is a little bit reverse of what's over here. I must have done my orders different. So outside, alternating sides of the transversal. Okay, and then our last one is consecutive interior. Consecutive interior angles are going to be on the same side and interior. Right, because consecutive numbers are 1, 2, 3, 4, so numbers right next to each other. So consecutive interior angles will be on the same side and be in the interior. Okay, so let's go see if we can identify all of these based off of the names for the last example there. Very good. All right, so looking at this diagram, what would be all of the corresponding angles? I'm going to start with angle 1. Angle 1 would correspond to what on the other side? 5.
On the other side?
Yep.
5.
So top left, 5. So angle 1 and angle 5 would be a corresponding angle pair. What about with 3? What would match up with 3? 7, good. So angle 3 and angle 7 would be corresponding with each other. What about 2? 6, good. And that leaves us with 4 matching up with 8. So you have 4 different types of corresponding angle pairs, which makes sense because you have 8 total angles. So if you were to pair them up, you should get 4. Okay. All right. How about alternate interior? So interior angles. We only have 4 interior angles. If I had to pair them up,
Angle 2 and 7.
and 7 would be on different sides. And then 4 with 5. Right? Because I only have 4 angles in the interior, so if I pair them up, I only get 2. They have to be on opposite sides. Alternate exterior. So now we're moving to the exterior, which I only have 4 angles on the exterior. Angle 1, go to the other side. What's on the opposite side of the transversal? 8, good. And then 3 would match up with 6. Nice. And then the last one, consecutive interior, which is just the same as kind of like same side interior. Huh?
2 and 5, 4.
Good. So angle 2 and angle 5, angle 4 and angle 7. Nice. Any questions?